Okay, I want to talk about a situation in which we have an object that's being launched off a cliff. And so far, when we've talked about projectiles, we've talked about when they're launched horizontally. Okay, well, the fact is that when you launch a projectile, you don't always launch it horizontally. And I mean, unless you're specifically trying to, you probably didn't. Okay, and so we have this other kind of projectile in which the projectile is launched at an angle. Now, all the same rules apply, okay, but one thing that's really important is that the initial velocity for y is no longer equal to 0 meters per second, okay, because initially it's moving upward, okay, and so we don't use that anymore, all right. Instead, we have to account for the fact that it's moving upward initially. Okay, so the way that we do this, we're going to go about it the same way we have with the previous ones, okay, but if we think about again the forces acting on this projectile as it flies through the air, the only force acting on it is gravity, its weight, okay, and so that's causing it to accelerate downward, okay. Is there a force to the side? No, which means from a horizontal perspective, the motion is balanced, okay, which means it moves at a constant speed. So we have some horizontal velocity, and it's going to stay the same the entire time. Okay, meanwhile, we have this vertical component velocity that's starting upward, and it's over time, it's going to slow down until eventually it comes to a stop and turns around and speeds up downward. And while all this is happening, it's moving horizontally at a constant, unchanging speed. Okay? In order to analyze this situation, the first thing we have to do is figure out, well, what is the velocity horizontally? How fast is it moving this way? And how fast is it moving upward? Okay? And the way that we do that is by doing something called taking our velocity and breaking it into components. Now, we talked about this really briefly last semester with forces. Now we're going to do it again with velocity. Okay? So if we have this velocity vector, in which it's traveling 40 meters per second. If you were to look at it underneath, you would see it going a certain speed horizontally. When you were to look at it from the side, looking this way, it would go a certain speed up. Okay? And so we can find each of these things, and it turns out that they're completely independent of each other. Okay, so this one we would find by multiplying 40. If this is a 60-degree angle, this would be the adjacent side, and that would be the hypotenuse. Okay, and so we use cosine, right? From SOHCAHTOA, cosine is adjacent over hypotenuse. Okay, so the way we get that is that 40 is, the angle 60, the cosine of the angle 60 is equal to the adjacent side, which in this case we'll call x, over the hypotenuse, which is 40 meters per second. Which means that if we solve this for x, we get that x, that horizontal velocity, is going to be 40 meters per second times the cosine of 60. Okay? We repeat the same process with sine for y, and we get that the y velocity initially is going to be equal to 40 times sine of 60. Okay, so we'll punch those into our calculator and see what we get. Okay, so we do this and we find that our vertical component for velocity is going to be 34.6 meters per second, while the horizontal component will be equal to 20 meters per second. Okay, so let's go back to this scenario. Let's say that we're at the top of a mountain or a cliff. Let's say it's 100 meters tall. Okay? I launch this projectile and I want to know, let's say, how far away from the base of the cliff it lands. Okay? So we can set up our table. We'll talk about horizontal and vertical motion. Okay, in the vertical sense, we have acceleration of 9.8 meters per second squared. It's totally arbitrary. I can say that up or down is positive. I'll continue to say that up is positive. Okay, which means that it's the downward acceleration, so negative 9.8 meters per second squared. We also know that it's going to hit the ground 100 meters below where it started, so that's going to give us a displacement of negative 100 meters. Okay, we know that our initial velocity for y, initially it was traveling upward at a speed of 34.6 meters per second, so that would be 34.6 meters per second. And we don't know our final velocity for y. We are solving, though, for the amount of time. Okay, in the horizontal perspective, remember the only equation we can use over here is this one, because it's moving at a constant speed. So we have velocity and displacement. Those are only two variables here. Okay, well, that horizontal velocity, it's moving 20 meters horizontally every second. And finally, for our, sorry, I put that in the wrong spot, 20 meters per second. And we're solving for displacement. We want to know how far it's going to go horizontally. Okay, well, in order to find that, using this equation, if we know what this is, and we want to solve for this, we're going to have to find this time first, okay? Well, we don't know what time is, and we can't use these values to find time. We can look over here in the y direction, in which we have acceleration, and say I have 1, 2, 3 pieces of information. That's enough to find a fourth. In order to do so, I need to find an equation that compares these four variables, okay? And I have an equation that does that, okay? But I'm not going to use it. I'll explain why. If we use this equation right here, and it's totally up to you if you want to try it out. For the sake of demonstrations, I'm not going to use it because the reason why is this. If I substitute negative 100 meters, okay, that's equal to 34.6 meters per second times t plus 1/2 times negative 9.8 meters per second squared times t squared. Okay, you'll see that I have t and t squared. I can't solve this just using basic algebra. I have to go another step and use the quadratic formula or graph it and look for the zeros. Okay, to avoid that, what I'm going to do instead is use a different equation to start. Okay, I know that I can use this equation to find the velocity just before it hits the ground. Okay, and then once I do that, I can find the time. So, to do this, v squared equals initial velocity 34.6 meters per second. We'll square that plus 2 times negative 9.8 meters per second squared times negative 100 meters. Okay, I'm going to do some simplifying real quick. I'm doing some quick simplifying. 34.6 squared is 1197. These become meters squared per second squared. And over here, 2 times negative 9.8 meters per second squared times negative 100 meters is going to be 1,960 meters squared per second squared. Can add those together. And finally, I'll take the square root to find that the velocity here is going to be 56.2 meters per second. And since it's going downward, I'm going to say that it's negative 56.2 meters per second. Okay, now I can find time using this equation. Alright, I'm going to substitute in negative 56.2 meters per second for final velocity. I'm going to put 34.6 meters per second for the initial velocity, and then acceleration will be negative 9.8 meters per second squared times t. Okay, so to solve this, I subtract over the 34.6 and divide by 9.8. I get negative 90.8 meters per second equals negative 9.8 meters per second squared times t. Okay, divide by 9.8 from both sides. Okay, bringing the seconds up, and I get that the time is equal to 9.3 seconds. So I put my time, 9.3 seconds. Okay, and finally, since I want to find displacement, I have time and velocity now, so I can say 20 meters per second is equal to my horizontal displacement divided by the time of 9.3 seconds. So to solve this, I multiply by 20, okay, and I get a displacement horizontally of 185 meters. Okay, what that tells us is that when this projectile hits the ground, it will be 185 meters away from where it started. Okay, so as we continue to talk about projectiles, one thing I want to point out, if this is the path of a projectile, I want to say a couple things that we know. We know that right here, the velocity in the y direction is equal to 0. Okay, but at this point, we still have that horizontal velocity. Okay, at this point, that horizontal velocity is the same as it is right here, the same as it is right here, the same as it is right here. Okay, we have some initial velocity for y upward. Okay, here, whatever our initial velocity was, this is going to be equal to negative of our initial velocity. Okay, it's going up, it slows to a stop up here, and it speeds up on the way down. Okay, we know that it's gone to the same velocity in the opposite direction right there. Also, the amount of time it took to get from here is equal to the amount of time it takes to get to here. Okay, so there are a couple little hints or tools that you can use in problem solving. Okay, so what I'm going to do right now is have you try one out. So we are at the top of a 200-meter drop. Okay, and then we're going to launch a projectile at an angle of 40 degrees with a velocity of 45 meters per second. So your first step will be to take your 45 meters per second and find the components using sine and cosine. So go ahead and do that. Okay, so the next piece, so you've done this, you should have found that the horizontal velocity is 34.5 meters per second. The vertical velocity is 28.9. I found this vertical one by multiplying 45 times the sine of 40. I found the horizontal one by multiplying 45 times the cosine of 40. Okay, now I want you to set up your table, x and y. We fill in the variables, velocity for x, displacement for x, initial velocity for y, final velocity for y, acceleration for y, and displacement for y, and then time down here. Now we're going to say that up is positive. Okay, so you know in this table you have 1, 2, 3, 4 pieces of information, and so I want you to correctly fill in those 4 pieces of information. Go ahead and do that now. So you should have gotten a horizontal velocity of 34.5 meters per second, initial vertical velocity of 28.9 meters per second, an acceleration of negative 9.8 meters per second squared, and a displacement of negative 200 meters. Okay, from here we want to find, our goal is going to be to find the horizontal displacement. So we want to solve for this. In order to find that, we need time. So go ahead and find time. If you want to find velocity first, you can, or you can just use the one equation and use the quadratic formula to solve it. Okay? Okay, so I use this equation right here to solve for acceleration, or to solve for, the final velocity. And from there, I found the final velocity to be negative 70 meters per second. That means that just before it hit the ground, it was still moving horizontally at 34.5, but at this point, it was now moving downward at 70 meters per second. Okay? In addition, I used that to find out how long it took to hit the ground. Well, in order for it to gain a velocity downward of 70 meters per second, that would take 10.1 seconds. So we have a time of 10.1 seconds. And now the last piece is to use our time with our horizontal velocity and our horizontal displacement to find how far it travels before it hits the ground. So go ahead and do that. To finish it off, I substituted my horizontal velocity for v and 10.1 seconds for t, and I found that it's going to travel a distance of 348 meters horizontally before it hits the ground. Okay, so that would be my horizontal displacement.